So across a number of disciplines, intellectual disciplines over the last 40 years, a problem made itself manifest, probably 60 years. It emerged in artificial intelligence, and it still bedevils our attempts to make autonomous robots. You notice there aren't any. Musk is getting close with those cars, which aren't cars, by the way. Those are autonomous robots. They just have wheels. And so don't be thinking those are cars, because they're not. Any more than the car was a horseless buggy. And so, but apart from that, we don't have them operating in the world, and there's a variety of reasons for that, but here's one of the most fundamental reasons. When AI researchers started to try to make machines that could act in the world, they needed to make machines that could perceive the world and then act, because that's what they thought we did, was perceive the world and then act. And it turned out that the action was a lot easier than the perception. The AI researchers stumbled across a problem, and the problem, it's a really deep problem. The problem is that the world is so complicated, it doesn't seem possible to perceive it. And the reason for that is that there's an indefinite number of ways of looking at everything. And I really mean everything. I don't know how many of you have ever played around with Photoshop, but it can be maddening. You know, you take a single image, it's just one image, it's not even that high resolution, and it's just indefinitely complex. You can just play with it forever. And that's just one two-dimensional image of, one slice of time. And then if you zoom in on a photo, you see that the borders between things aren't obvious at all. When the photo is focused in front of you and you see it the same way you see the world, you see very sharp borders between things. But when you zoom in, they're not there at all. It just fuzzes out, it's pixelated. Nothing's where one thing starts and another thing ends is not clear. And that's the case in the real world. But when we look at the world, it's just there. It's there in such an obvious way that we just think it's simple. What's the world made of? Well, you just look and you can tell. It's easy. Yeah, except, half your brain is working on that all the time. And it's so complicated, The center part of your vision is called the fovea. And every foveal cell has 10,000 cells that it's connected to in the primary visual cortex. And then all of those are connected to 10,000 other cells. And so it takes a lot of neural territory in order for you to see sharply. And so you just have this tiny little bit of high-intensity vision. And the way you cope with that fact is you dart it around all the time. And you're taking snapshots all the time, high-resolution snapshots, and aggregating them together. You don't see the world in a high-resolution way except at that focal point, and you use that to look at people's faces when you talk to them, for example. It's really expensive to perceive. It's really hard. And we don't know how we do it. And so and no one's cracked that problem. Not in any fundamental sense. That's why you don't have dishwashing robots. Like, how hard is it to be a dishwasher? Well, try to build one and see. It's really hard. And so those simple jobs, they aren't simple at all. It's hard to even build a machine that can do simple things in a simple environment. We have Roombas, and they're, what the Roomba is? That's a little automated vacuum cleaner. It's not really a vacuum cleaner. It's a little autonomous robot. And it was built by a man who was very cognizant of this problem, by the way, Rodney Brooks at MIT, a real genius. He understood that the problem of perception was paramount, and so he built robots that really didn't perceive. Like the Roomba doesn't really perceive, it navigates. It has a more practical orientation to the world. It doesn't try to see the world and then operate within it. And he believed that we wouldn't be able to crack the problem of autonomous artificial intelligence without building entities, robotic entities from the bottom up, very simple systems that just acted, and then we'd have to scaffold on top of that to solve the problem of perception, which would be, in some sense, a reduplication of the entire process of biological evolution. And so all that's behind your Roomba, by the way, and much more. Okay, and so you think, well, so what? But here's another problem. At the same time, the AI people figured this out. Cognitive scientists were working on the problem, and they ran into the same difficulty, this problem of perception. So that merged in two fields, let's say. People who worked on the visual system, for example, started to find out that when we looked at something like this, you think, well, you see that, and it's an object, and then you decide you grip it with your hand, but that isn't really how it works, because what the hell do you know about how you see things? And when you see that, your eyes map the shape onto your hand, and the notion that you understand what this is means that you can get a grip on it, and that means in some sense without your hand you couldn't see, and that means that action is extraordinarily tightly tied to perception in a way that we didn't really count on, because we thought the world's made out of objects. You think about what you do in relationship to the objects, and then you go do it, and that's just not how it works. Partly because it's way too slow. That's one problem. You know, if you're walking down a path and you see a snake, and you think snake, and then you jump, the snake's already like bit you 10 times. You have to be way faster than that, and so snake makes you jump, and that's the perception of snake. I actually saw this at one point. I was walking along a cliff in San Diego in March, and there was a friend of mine in front of me who's very tall, about 6'5", and his little daughter was in front of him, and when she walked down the path, a rattlesnake rattled beside her, like right beside her. She jumped right onto his shoulders, just like a cat. I didn't know human beings can do, apparently we can do that. And, you know, a snake can strike very rapidly, and so if you're sitting around thinking snake, you're dead. And so you have systems, like very low-level systems, in some sense, way under your conscious vision that will map that pattern onto jump, and maybe you're fast enough so you don't die. And so much of your perception is mapped onto action that, well, it's hard to overestimate.